Day 817 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3518, smallest palindromic rearrangement 2. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a palindromic string S and an integer K. Return the kth lexicographically smallest palindromic permutation of S. If there are fewer than k distinct palindromic permutations, return an empty string. Note, the different rearrangements that yield the same palindromic string are considered identical and are counted once. Alright, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, as you can see already, this is the second version of the problem that we did yesterday, so if you missed yesterday's problem, go ahead and check that out. Now let's get into example 1. So in example 1, our input S equals a string A, B, B, A, K equals 2. So that means we want to find the second smallest lexicographically smallest palindromic permutation. Matter of fact, let's go through the definitions. It says a palindrome is a string that reads the same forward as backwards. So as you can see, this reads the same forward and backwards, and this reads the same forward and backwards. They're both palindromes. A lexicographically smallest palindromic, or it says a string is a lexicographically smaller than a string. A string A is lexicographically smaller than a string B if in the first position where A and B differ, string A has a letter that appears earlier in the alphabet than the corresponding letter in B. If the first min A.length, B.length characters do not differ, then the shortest string is the smallest one. Boom, and then finally a permutation is a rearrangement of all the characters in the string. So now let's back to example 1. We have this, right? Boom. Then we rearrange it to this, but it's still a palindrome. It says the first distinct palindromic rearrangements of A, B, B, A are A, B, B, A. So this is the first one because this is the lexicographically smallest palindrome that we can create with these letters because it starts with A, B, right? So then the second smallest would start with B, so then it goes B, A. This is the second smallest, and we want the second smallest because K equals 2. So lexicographically, A, B, B, A comes before B, A, A, B. Since K equals 2, the output is B, A, A, B, and that's how we got it. Boom. Now, just in case that didn't make sense, let's take a look at example 2. So in example 2, the input S equals a string AA, K equals 2, the output is a blank string. Explanation says there's only one palindromic rearrangement, AA. The output is an empty string since K equals 2 exceeds the number of possible rearrangements. Boom! Now, in example 3, the input S equals a string BACAB, K equals 1. The output is a string ABCBA. It says the two distinct palindromic rearrangements of BACAB are ABCBA and BACAB. Lexicographically, ABCBA comes before BACAB. Since K equals 1, the output is ABCBA. So in this case, you can see that this is lexicographically smaller than this because this starts with A and this starts with B. So we just take this and make it lexicographically smaller than it already is, and we get this. So boom, y'all, I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we're going to do is we're going to convert the string into an array so characters can be accessed by index. So we're going to say let S equal an array, open up the parentheses, pass in S. Boom. Then only the left half of the palindrome needs to be constructed. The right half will simply be reversed to the left of the left half. So we'll say let partition equal s.count divided by 2. Boom. Now we're going to count the frequency of each character that appears in the left half of the original palindrome. So we're going to declare a variable called bucket. We'll say colon. That's going to be an array of integers. And we're going to set that equal to an array. Open up the parentheses. We're going to say repeating, colon 0, comma, count, colon 26. Boom. Then we're going to come underneath this, and we are going to say for I in 0 dot dot less than partition. We're going to open up the brackets, and we're going to say guard let char equal s square bracket I, come outside of that, dot ASCII value, else we'll open up the brackets and we will continue. Boom. Then we're going to convert the character into an index. So we're going to come underneath this and we're going to say bucket square bracket int, open up the parentheses char, come outside of that, say minus 97, come outside of that, and we're going to say plus equals 1. Boom. This will hold the left half of the kth smallest palindrome. This next variable that we create, we're going to declare a variable called left, colon, it's going to be a string, and we're going to set that equal to a blank array. Boom. Then we're going to track the lexicographical position of the palindrome currently being built by declaring a variable called start index. We'll set that equal to 1. Boom. Then we're going to build the left half one character at a time. So we're going to say for POS and 0 dot dot less than partition. We'll open up the brackets. And then we're going to try replacing every possible letter in alphabetical order by saying for I in 0 dot dot less than 26. We're going to open up the brackets. And we're going to skip letters that are no longer available. So we're going to say guard bucket square bracket I, come outside of that, is greater than 0, else we're going to open up the brackets and we're going to continue. Boom. Then temporarily we're going to use one copy of this letter. So we're going to come underneath this, we'll say bucket square bracket I minus equals 1. Boom. Then we're going to count how many valid permutations can be formed using the remaining letters. So we're going to say let ways equal permutations, open up parentheses, partition minus POS minus 1, comma, bucket, comma, K. And if the kth palindrome falls within this block of permutations, keep this character. So we'll come underneath this and we'll say if start index plus ways is greater than K, we're going to open up the brackets and we're going to say left dot append, open up the parentheses, character Unicode dot scalar, open up the parentheses, I plus 97, come outside of that, question mark, quotation marks, A. Boom. Then we'll come underneath this and we'll say break. Now, otherwise, we're going to skip over this entire block of permutations, restore the character, and try the next letter. So we'll come underneath this and we're going to say bucket square bracket I, come outside of that, plus equals 1. Boom. Then we're going to say start index plus equals ways. Boom. If we couldn't build the full left half, then there aren't enough palindromes. So we'll come right here and we'll say if left dot count is less than partition, we'll open up the brackets and we'll return a blank string. Boom. Now we're going to assemble the final palindrome. So we'll come underneath this if right here, declare a variable called res colon string, set that equal to left. Boom. Then we're going to say if s dot count mod 2 does not equal 0. We're going to open up the brackets and the odd length palindrome. We're going to say res plus equals string, open up the parentheses, s, square bracket, partition. Come outside of that, we're going to say plus string, open up the parentheses, left dot reversed, put the parentheses. Then we're going to come right here and we're going to say else. We're going to open up the brackets, and even length palindrome, we're going to say res equals res plus string, open up the parentheses, left dot reverse, put the parentheses, boom. Then we'll come right here and we're going to say return res, boom. Then we're going to come underneath this, we're going to say private func cone, open up the parentheses, underscore n colon int comma underscore m colon int comma underscore k colon int. Come outside of that is going to return an int. We're going to open up the brackets and we're going to declare a variable called res. We'll set that equal to 1. Boom. Then we're going to use the smaller side of the combination formula to reduce the number of iterations. So we'll declare a variable called m. We'll set that equal to min. Open up the parentheses m, comma, n minus m. Boom. Then we're going to come underneath this and we're going to say guard m is greater than or equal to 1. Else, we're going to open up the brackets and return res. Boom. Then we're coming underneath this and we're going to say for I in 1 dot 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 m. We're going to open up the brackets and we are going to say res. We're going to incrementally compute the combination value. So we're going to say res equals, open up the parentheses, res times n, open up the parentheses, n minus I plus 1. Come outside of both of these parentheses and we're going to divide it by I. Boom. Now, no need to compute values larger than k. We're going to return k plus 1 as a sentinel, meaning more than k. So we're going to say if res is greater than k, we'll open up the brackets and we'll say return k plus 1. Boom. And then we'll come underneath this and we'll say return res, y'all. Boom. Now come underneath this because we have another helper function. Let me see. Oh, there it is. All right. We got another helper function we need to create. We're going to say private func permutations. We're going to open up the brackets, underscore rem, colon, and comma, underscore bucket, colon, square bracket, and so an array of integers. Come outside of that, comma, underscore k, colon, and come outside of that, we're going to return an integer. Boom. Now we're going to count the number of distinct permutations that can be formed from the remaining character frequencies. So we're going to declare a variable called ways, set that equal to 1. Declare another variable called rem, set that equal to rem. Then we're going to process each character's frequency by saying for I in 0 dot dot less than 26. We're going to open up the brackets and we're going to say guard bucket square bracket I is greater than 0. Else, we're going to open up the brackets and we're going to continue. Boom. Then we're going to choose positions for this character among the remaining slots. Multiplying these combinations gives the total number of distinct permutations. So we're going to come underneath this and we're going to say ways times equals cone, open up the parentheses, rem, comma, bucket, square bracket, I, comma, k. Boom, we're going to stop early if we've exceeded k, so we'll come underneath this and we'll say if ways is greater than k, we're going to open up the brackets and we're going to break. Boom. Then we need to reduce the number of remaining positions by coming underneath this and we're going to say rem minus equals bucket square bracket I. Then finally, we're going to come all the way right here, and we could just say return wage, y'all. Boom. That should be all she wrote. Let's give it a run. Make sure. Okay, cannot find POS and scope. Where, let's see, where we get our error. Okay, let's see, y'all. Oh, this should be POS. It should not be post. So now let's run and see if that fixed it. Okay, we got another error. Oh, this should be plus 97. So now let's run that. See what that does. Come right here. And we are going to say, hold on, y'all. This should be res times this end shouldn't be right there. Boom. Now let's see. Let's see, and look at that, y'all. 32 milliseconds, 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, y'all, make sure you get one more look at the code. This is the top part. This is the middle part. This is the bottom of the middle. This is under that. This is the bottom of the code, y'all. And yeah, with that being said, excuse me. This is the bottom of the code, y'all. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.